Okay, I'll get started. Thank you very much for coming. And there's a great choice in the schedule today, so thank you for choosing this session. My name's Simon Maple. I'm a developer advocate for Zero Turnaround, and today I'm going to be talking to you about profilers. So how many of you are using profilers today in your jobs? And do you personally use them, or is it just your groups? Mostly yourselves, right? Okay, cool. So we're going to be talking about a few things in this session. First of all, a little bit about me. If you wanted to follow me on Twitter and hear my ramblings, you're welcome to @SJMaple. I work as a developer advocate for Zero Turnaround, which is an Estonian company. They create two products, one called JRebel, one called XRebel. You've probably heard of JRebel mostly. XRebel is a much newer product. I also help out with Geek Out EE, which is a conference in Estonia. We had it only a couple of weeks ago. And I also help out with Devox UK, holding the branding, Devox UK, which was last week. I'm also in the program committee for Java 1, and also Dev Nation, which is happening this week as well in Boston. I'm also a writer for Rebel Labs, which is a content arm of Zero Turnaround. So we produce a whole bunch of technical blogs, a whole bunch of technical reports, which are all freely downloadable for you to use. I'm a Java champion and a Java 1 Rockstar speaker. Java champion mostly because of the VJug, which is a virtual user group. Anyone heard of the VJug? Quite a few, cool. Everyone who hasn't, go to virtualjug.com and sign up. It's a free online-only Java user group. So we get the best speakers like James Gosling, Josh Block, Aaron Gupta, Heinz Kibbutz, loads of top speakers. And they speak for us live on the virtual jug. And you can interact with them, ask them questions, and loads of cool stuff like that. So that's something I created about a year and a half ago. I'm also one of the co-leaders of the LJC, which is the London Java user group. That's pretty much one of the main things that got me into community. Okay, so the agenda, we're going to talk about performance tools in general. First of all, what are the different groups of performance tools and the different types of tools which exist in the different groups. We're also going to look at a report which I'm currently writing for Rebel Labs, and this report is basically an overview of a survey which went out only a few months ago, asking developers just like yourselves a whole bunch of questions about which tooling they use, when they run their tooling, how complex their applications are, and we've got some interesting information. So I'm going to share. It's not even out yet, so I'm going to share this really early for you guys to have a look at. And they're going to have a look at the differences between sampling and tracing. Different profilers choose different methods of how they can get their data. So I'll show you the difference between the two. And we'll finish talking about XRebel. And who's heard of XRebel here? A few people. Okay, quite a lot actually, cool. So XRebel is actually a very new profiler which has come out. And we do things very differently to how existing profilers work. We do things at a different stage, and we provide the information differently to you. So I'll also give a quick demo of that. This is a screenshot of the XRebel tool. And this is just really a teaser, as we'll go into it in more depth. So looking at the performance tools, the three different categories of performance tools are really Java monitoring tools, Java profilers, and Java testing tools. And the distinction is pretty large. A Java monitoring tool is very similar to a kind of APM. So you're monitoring your entire system. It's separate. It's typically done as a separate process. So you're going to be doing monitoring on general either VM or your actual machine. Seeing the state of that, seeing the state of the JVM itself, including threads, memory, that kind of stuff. You're looking at the spread across of CPUs. You're doing a full system check. That's really where APMs like App Dynamics and New Relic and people like that sit. The questions that they kind of answer is my environment broken? So if you're looking in thinking, I have no idea where to start, but I just want to know the general health of my environment, you go for a Java monitoring tool or an APM. It tells you kind of where the problem is going to be, but it gives you very little detail. So you might know, where to look in more depth. When we go for a look at a Java profiler will give you more information about what is wrong. and perhaps even how you go about fixing it. Some profilers will actually give you information exactly how to fix your potential performance problem. We're going to be focusing on Java profilers for this session. Java testing tools are equally interesting. If you guys have probably heard of like JMeter and Gatling and these kind of tools, what they effectively do is they push load onto your environment. So you might use JMeter or Gatling to say, I want to run my application against 200 threads, each causing 500 requests to be made to my application. And at this point, it will give you a full throughput, it will give you an average per request, and you can baseline your application. And this is super important because when we work with performance testing, we want to kind of like do a couple of things. When you change anything in your code for performance testing, you want to be able to measure that change straight away, and you can straight away measure and determine whether that change was good or bad. If you're not measuring against a baseline, then you're coding blind. There's nothing to test against. So the Gatlings and the JMeter tools are really important to create that baseline before you start, and then your future changes will alter that baseline. Okay, so we're going to talk about. Oh, actually, yeah, this is a separate report, actually. This is a free Rebel Labs report. You're welcome to go to rebellabs.org and you can grab this report. We actually look into those 3 items in a load more detail. And this is, again, like I say, an entirely free report. This is written by myself and Oleg Shelahev from Estonia. And we talk about the differences between the tools, and we look into a whole bunch of different tools in a little bit more depth. But what I want to share with you is this survey. Now, on this survey, we asked a whole bunch of people. I think we had over 1,500 responses, and we asked them a whole bunch of questions. So I want to share this data with you. So first of all, we want to talk about we want to look at who actually filled out the survey. And the people that filled out the survey are typically mostly developers, pretty much all technical. 65% software developers, 14% architects, 13% team lead. So you're looking at a highly technical environment. Interestingly, only 2% were performance engineers. And I kind of guess I've got 2 reasons for this. One, because maybe performance engineers is kind of turning into a bit of an old-fashioned thing now, whereby with everything moving left, developers are doing more of the performance testing themselves. The second thing, I guess, is the people that we typically have in our social groups and social media groups are probably mostly developers, so it's probably a little bit skewed on that as well. The application people typically work on web apps. Is that pretty much the same as here? Most people on web apps, yeah, a lot of nods. A few on desktop, few on batch, some others kind of like middleware style products, but the majority web apps. So, when do people test? This is really interesting. A lot of people are saying they actually test while they code. I'm not sure if that can be seen as every single developer, but largely you have a lot of people in staging, a lot of people in production, and a lot of people, the majority, in this kind of system test, integration test. This is a multiple choice answer, by the way. But yeah, this is interesting to see. Most people kind of wait for that build to be available with everyone's code in, and then they do typically, run their benchmarks, do their performance tests, try and tune their environment. Tools that people use, Visual VM was interestingly the highest in this. JProfiler is pretty much the profiler with most market share between that and kind of YourKit. Java Mission Control, who's heard of Java Mission Control out of interest? Okay, you see, even that isn't enough. There's like probably less than half the room people put their hands up. I'll talk about that a little bit later, but Java Mission Control is something which actually ships with the JVM. And is something that's actually got a really nice UI. It's very easy to use to get data. It's a little bit more complex to get usable data, but we'll look at that. Again, this was multiple choice, so it won't add up to 100. So how do people find their bugs? How do people know their bugs exist? The vast majority is actually from user reports rather than performance monitoring tools, interestingly. System faults and crashes, but typically the actual symptom that people are finding is not so much system crashes, but more so that people are suffering from slow requests, and this kind of suggests why the majority previously was from users suffering slow requests, and this kind of thing is actually, obviously, I don't need to tell you guys, this is crucial to gaining market share for your businesses, right? If people have a slow request, they go somewhere else. If a service isn't working for whatever reason, because it's slow, people will use someone else's service. The root causes are very, very interesting. The biggest one is the slow database queries. Any DBAs in here? Database administrators? Just one. Okay, I won't be too rude. But it's always people always blame the DBA, right? It's not always just that down to the database. There's a whole bunch of different I/O that occurs in your environment, but very often, the majority of the work is pushed to the database, and a lot of people will see that coming up. And also, just because there are too many database queries, that might not be a database issue. It's typically through some coding issue, whether it's a Hibernate issue or a JPA issue. Who here uses Hibernate? There's always a good bunch of people. Keep your hand up. Keep your hand up if you think one line of Hibernate code is the same as one SQL statement. A few people, you'll be amazed how many SQL statements can be created from one single line of Hibernate. We'll show you this a little bit later. There are n+1 queries, which are huge. Do you affect users? Yeah, most people say their performance issues tend to affect users in production. Who are the heroes? Who here fixes performance issues? The majority, I'd say. Interestingly, and this is a multiple choice, but 94% of respondents say that development fix their performance issues. And this is super interesting, because if we cast our mind back a few slides, we'll remember that a lot of the bugs were found in system test or production. Yet it's the developers that are fixing this. So we have to go all the way back to the development phase. And one of the things that we want to look at today is about how we can fail fast and fail early. So if we can find, for example, testing. Typically before Agile, we had a very defined development stage, then a very defined functional test stage, and a very defined system test stage, and so on. And we were able to pull as much as we can left, so that within the iteration, you did both development and test. So the code you produce is of a much higher quality. And this is what we're trying to do with performance as well. We want to pull performance left, so that you can find your bugs as early as you possibly can. And if 94% of developers are fixing performance style bugs, we want them to fix it when they're writing it, not when they're in system test and they wrote this performance bug 2 months ago. We don't want them to fix it then, because other people will have built on top of it and they're fixing a numerous number of people's bugs. So when do people, or how often do people profile their code? It looks pretty reactive, and not the cool, funky reactive that everyone wants to be, but this reactive when people tend to profile their code when they see issues. So they find a bug, maybe from an APM, maybe from their users, and they profile their code to understand more about that bug or that issue. So people don't tend to have a regular profiling schedule. They do it when they need to. Just so you know as well, on information that goes with this, people's application releases really in the kind of months, the majority. So maybe we're not as agile as we think we are, but that's interesting. How much time do people spend testing in a release? So if our releases are typically a couple of months, people only spend either a couple of days or maybe even no time at all in running that performance test. So this is quite interesting now. And how much of an impact did your performance or testing make? We don't compare or know how to compare. 20% almost of people don't even measure their performance testing after they've done it. The vast majority, if we add these three together, are at least half as fast again. So it's good to see. It's good. Well, we'll see in a little while a graph which will show you this. Okay, so that's all I had for stats. I will be writing this up, and I'm going to be pivoting a whole bunch of data to do some comparisons, and that will hopefully be available at the end of July, so I'm working on that now. So when we look at the journey of performance, every application will typically go on a journey whereby it starts slow, and we want to really ramp it up and make it much, much faster. The question is, what does that journey look like? A guy called, who's heard of Alexei Shipylev? Okay, if you haven't heard of Alexei Shipylev and you're really interested in performance, you should definitely follow him on Twitter. He's a really super smart guy working for Oracle. He's one of the few people in our industry who really gets performance. He's also awesome on the Java memory model. He gave a session on the VJUG on the Java memory model just recently. And this is the graph that he grew. This is the graph that he drew, which is the typical path that any application he believes will go through on its performance path. If I draw this graph out without the whiteboard, just to see it a little bit clearer, he's basically comparing the complexity of your code versus the performance of your code. And we start at A, and we're on this path to E, all the way through to E, and we basically stop where we feel comfortable based on the requirements of your application. So basically, we start here. We've effectively done our first code drop of our release. We can here on this path from A to B. This is really about removing duplicate work, inefficient API calls, removing the stupid work from our own code, refactoring to make it flow better. All this kind of thing can make our code really much faster. And this is actually one of the pieces of most important change, because you get the most growth from it. The next part is from B to C. This is typically where our profilers do their work. It's hard work to get from B to C. It is going to cause you to have more complex code, but it's still maintainable. As soon as we're in this kind of stage, we're doing a balance between high-performant code and complex code. It's about that code maintenance versus performance. Anything above C, you're kind of in that last 5% now, or last 1%. You really only need to be here when the kind of milli-nanoseconds really count, whether you're in if you're working for a financial house or some kind of bank where split seconds absolutely count because you lose money otherwise. Then you don't so much care about how maintainable your code is. It's about making that money. People tend to stop here. Smart people, I guess, tend to stop here unless there's an absolute need for it. Now, when we look at performance and profiling, there's two different areas which people typically think about when they profile. You can look at CPU profiling, or you can look at memory profiling. Of the two types, you can consider CPU profiling is really about optimizing your latencies. Memory profiling is about optimizing your memory usage. They're two amazingly different talks. We're going to be focusing just on CPU profiling, or application profiling, as it's called. You can follow two different methods, as suggested here, tracing or sampling. And different profilers will do different things. YourKit is an interesting profiler because it does both, and you can switch on between both. There are advantages and disadvantages of doing both, which we'll look at. Tracing will really follow your method invocations, so it's following your path all the time. Sampling is about aggregating data. Okay, it doesn't follow your entire path, but you will take samples at every point, and then it will do a best guess as to where you spend your time by aggregating all that data together. So what is a sample? Well, I guess a thread dump could be considered a sample. Performance experts will just say, yeah, press control break, or send a kill -3 to your process. That's all you need to do, and you'll get this amazing heap dump. And it'll be a wonderful bedtime reading because you'll probably fall asleep halfway through it. And really, there's not a huge amount in there unless you understand what you're looking at. Okay, this isn't like developer-friendly style information. So this is great for performance experts that know exactly where they want to look at. They can see the problems, almost like reading through the matrix. When that guy says, that's a blonde, that's a whatever. It's like looking for those patterns, and performance experts will see them very, very clearly. This is a your kit example, and here this is your kit in sampling mode. Now, what we've set here is a sampling interval, and we've got a sample count as well. A sampling interval is the duration between samples which we request from your kit. So here we're saying every 20 milliseconds, I want you to take a sample or a snapshot of the environment and tell me and aggregate the data across multiple snapshots. So here we've got a sampling interval of 20 milliseconds, a sample count of 4, and we can see from the time here, yeah, we're probably looking at about 3 or 4, you can look at that and say, yes, between 3 and 4 samples. And basically what we do is we look at what your kit's doing is it's looking every single sample. It's saying where is my what is on the CPU at the time? Where are my threads at the time? Which methods are they in? And if it does that at a granular enough level, many times, you will understand, or you can guess how much time is spent in those just by averaging those times out. So if, for example, I do 10 samples and 7 out of 10 times I'm in a certain method, I can guess average that 70% of my time is spent in that method. So the lower the sample, the more uneasy you can be about your results because you might have anomalies. If I decrease my sampling interval, which essentially increases my sample count because I can have more of them, we get a much finer grained environment. So as a result, I can trust these more because I'm taking more samples. So yeah, around 100 plus milliseconds, so that accounts for this time. Interestingly, one thing we can see here is a your kit package. So samplers can actually profile themselves, which I guess is possible. If we're in that method at the time of a sample, then we're sampling ourselves. So that's quite interesting as well. Any questions so far? Feel free to just shout out a question if you've got one. Okay, so sampling. Here we have a kind of map, I guess, of our flow through our application. We have 4 methods: main, foo, bar, and baz. And in each method, we're going to make an invocation. So here we're going to be in main, here we're going to be in foo, here we're going to be in bar, and here we're going to be in baz. So we go up to baz, then come back to foo, back up to bar, and all the way down and so forth. This is our flow, and as we come across, this is our time. What we can do is as we go through our JVM time, we're slowly sampling at different points. And this is great for when we just want to aggregate stats because we want a kind of basic general understanding of what our application is doing. But one thing you'll notice is baz at the top here is never captured because a sample point, because at the time we were sampling, we happened never to be in that position. We could have had these absolutely everywhere, but been very, very unlucky. And it's just how sampling works. Sampling is not a definitive way of profiling. It's a way. The advantage of sampling over something like tracing is that it's actually cheaper for you to do. As you're not instrumenting your code, and we'll look at that later, we're just looking at the JVM at certain points. It's actually costing us a lot less, so it's cheaper for us to do that. And that's one of the great things about your kit, actually. In your kit, you can actually switch between sampling and tracing. So you can run with your kit, and then all of a sudden, as soon as something looks a bit shady, you can switch across to tracing, and then follow some requests, which is very interesting. Now, in terms of when we actually get the samples, we're very restricted actually by the JVM as to when we can grab these samples. I'm sure many of you have heard of safe points. A safe point is where pretty much the entire world, the entire JVM just stops, and certain things happen during these safe points. So for example, when we go for a garbage collection happens at a safe point because everything is stopped, nothing's moving. It can go in and be destructive, defragment, whatever it wants to do, and then the world, the JVM continues, and we can proceed forward. So rather than just sample at any point, our samples are always taken, not at every safe point, but they're always taken at safe points. I say always. Some profilers can get around that, but the vast majority of profilers will always take these at safe points. So how can we get around that? Because obviously, if we're only dealing with safe points, what if we say, there's a method somewhere or something, there's some piece of code somewhere which never has a safe point? There is a much lower chance of us actually hitting that code. So how can we get around that? Well, we can tame safe point bias, and this is where we look at Java mission control. Now, Java mission control is actually part of the JVM, and it uses a proprietary protocol to actually go in, and it can make samples at any point. It doesn't need, well, maybe not at any point, but it can create samples outside of safe point zones. As a result, Java mission control, or JMC, can actually get a less biased view of your running JVM. If you're on Java version 7, update 40, then you will have Java mission control as part of your JVM. It is actually extremely cheap because it's part of the JVM. It has a lot of access to kind of the undercover APIs. You can actually run it in production if you wanted to. It's that low performance overhead. It does cost for use in production, but it's entirely free during development. So do check that out. I think it's just JMC in the bin directory, or maybe somewhere else. But absolutely check that out. You've got two modes. One is this kind of JMX mode, where you can actually ask the JVM questions of certain values. You can change values and push that through. There's another mode where you actually need to pass in, I can't remember what it is, but you need to pass in a JVM argument just to say you want to enter this mode, and it's called flight recording mode or something like that. And the flight recording mode is super cool. You basically say, I want to view, 1 minute of the JVM, and it hits the clock, starts recording, and it records huge amounts of information about the JVM, from your threads to your memory usage to loads and loads of stuff. You can work out deadlocks and loads of cool stuff. And it's got a really good dashboard as well. You can literally just click through these trees here and find useful information. It does tell you some useless information, and it can give you huge amounts of information. If you are very, very good and very, very experienced with kind of performance information, you'll be fine with something like this. You can find the information quickly. Honest Profiler is Honest Profiler is actually on GitHub. It's an open source profiler. It's written by Richard Warburton and other people, and it also has a different way. It uses JVM-TI, which uses a different way to take snapshots of the JVM. So it also avoids safe points. I think these are the only two pretty much that avoid safe points. I'm not exactly sure what state the Honest Profiler is in right now. There's not very much documentation, but it is around. It's free to use, so you can just play with it. I would maybe recommend using a different profiler, and as and when you need to avoid your safe point bias, then look to something like this to test it out. So let's look at Java mission control. I'm going to show you a couple of reasons why Java mission control. I've talked about why Java mission control is great, and you should all definitely check it out. But a couple of problems I find with it is for people who aren't Java performance experts. You tend to either get very obvious information that you can't necessarily do much with, or loads of information. So for example, java.util is hot. All right, yeah, we all use java.util. Everyone knows we're going to be using java.util a lot. Can you tell me some more information, please? So we get more information. And then we look at this and it's like, well, yeah, okay. How do I find a bottleneck? Where am I looking for a bottleneck? Basically, you get too much information. and then you're between two places, either the obvious or too much information. Now, from a performance expert will be able to look through these logs, look through these tools, and pick out performance problems. Very often with profilers, this is the problem. They're more focused towards performance experts than developers. Let's now switch to tracing. So we've talked about sampling. The other way that profilers can gather information is sampling. Is tracing. So tracing is all about instrumentation of code, and we'll take a basic example with this code here. So what we want to do with tracing is to be able to say, I want to understand the full path or flow of one of my application requests. So every single time you traverse through a class or a tree, I want to know about it, and I want it timed. So what we're essentially doing is instrumenting at the start and the end of a method where we enter and where we exit. Very, very similar to how you would perhaps add kind of trace into your existing code, so you understand the flow through your application. But here we're getting the current millis at the start, we're getting the current millis at the end, and then we just work out the difference. And then we can understand exactly how much time is spent in every single method. We're not estimating with sampling, we're working this out exactly. If you want more information than just current time millis, if you need more information than just milliseconds, you can use nanotime as well, which is fairly straightforward to get at. Nanotime will give you obviously time back in milliseconds. It depends how granular you want to be. Once a profiler has perhaps chosen at what depth it wants to get, it could put it into maybe some nice API call, and then you just have a profiler start, a profiler log on finally, and every single time, and this is instrumented into every single application class, every single flow through the application will have this absolutely logged. Method name, time, and you can see how long you go through. Now there is a couple of considerations we have to look through here. We have system.nanotime, system.current-time millis, both of which pretty much do the same thing. We'll talk about why nanotime may have problems in a second. There's also a third way of doing this, which is to use a parallel thread. And this parallel thread just has the job of grabbing the time constantly. And you can connect to that thread, and you can just ask what the time is. Why would we do this? Well, system.nanotime is very, very poor at concurrent requests. So if you're calling system.nanotime from multiple requests, you're essentially going to find a lot of contention, and you'll have a much greater slowdown in your profiler if you use system.nanotime. But if you need system.nanotime, or you want system.nanotime, a potential way of getting around that is to just use the parallel thread. And only the parallel thread is ever getting that nanotime. People can request what the current nanotime is from this thread, but no one, you're not getting any contention. Only one thread is ever getting the nanotime. And that's a really neat way of being able to avoid that concurrency. So there's a few ways of using the parallel thread. You can either have a sleep wake up, so you just sit there and sleep. You can have a yield wake up, so you just effectively just wait till you're called by some underlying operating system. Or you can have a busy loop. So you're effectively waiting until a condition, you're spinning around, waiting until a condition is available. Let's have a look at them. So here we have our profiler. We have a loop, and effectively on start. So when profiler.start is called, we just find our loop. We call get time, and then we just log it for now. What our busy loop is actually doing. Our busy loop is a separate thread, so implements runnable. We have a run method. We're creating a volatile time, and because we're going to have other threads coming in to grab this. And in our while loop, we essentially just grab the nanotime, set that to our time, and then just sleep. And every time we wake up, we grab the new time, set our new time, and sleep. And we just continue that. It's a pretty boring thread. But other threads can call our get time. and they get the latest version of our nanotime, and we only in one place ever call nanotime. So I mentioned there are contention issues on the nanotime. What are the contention issues? So reading memory is not free. Reading memory takes cycles, pretty straightforward. Each software layer is not free, and when we're talking about getting absolute times, we need to go through a number of layers before we reach the operating system to get that. It's actually a very expensive call. Alexei Shipilev, the guy I mentioned, wrote a blog. It's actually quite a long blog, but he gave some really compelling reasons and arguments as to why to use certain things on certain platforms and so forth. And we can look at his numbers now. So the piece was called Nano-Trusting the Nanotime. So here we have this split across 3 platforms: Linux, Solaris, apparently that's still a thing, and Windows. So Linux, Solaris, and Windows. We have 2 different types. We have Granularity Nanotime and Latency Nanotime. We'll look at latency first. This is the easy one. Latency is the amount of time it takes you to get the nanotime from the system. So if I make a call to get nanotime on Linux, it'll take me 25.524 plus or minus nanoseconds before I get that time back, before I actually understand what that time is. The other interesting one is this granularity nanotime. Now this is, if you consider the nanotime as this kind of like clock, it's not just constantly spinning, adding 1 nanosecond every time. Okay, it updates in chunks. So basically, the granularity nanotime is effectively the n+1, the next value that nanotime might possess. So let's say I grab the nanotime, and I grab the nanotime as a value we'll call n. The next time I call get nanotime, it's either going to give me, let's say I call get nanotime a couple of nanoseconds later, it's either going to get me n again, or it's going to be n plus 26.3. Okay, it's going to be one of those 2 values. It can't be anything in between. This is the granularity. Now we can notice on Linux and Solaris, it's reasonable. On Windows, it's 371 nanoseconds. So we're looking at a much less granular change. So when we created XRebel, it was very, very important to us that we kind of understand these limitations of different platforms to understand exactly how we're going to develop. That said, about Windows, it is much cheaper to actually grab the nanotime in the first place, but chances are it's going to be wrong or inaccurate because of the fact that it's not granular here. So, okay, let's look at the sleep time now as well. What happens when we say sleep with 1 millisecond? Are we going to be exactly 1 millisecond, or are we going to be different? Well, on Windows 8, we're going to have a minimum sleep time of 1.7 milliseconds. So if I say sleep for 1 millisecond on Windows 8, I will be at least 1.7 milliseconds. If I say it on Linux, I'm going to be at least 0.1 milliseconds. If I say it on OS X, at least 0.05 milliseconds. Now, if you're using VirtualBox and Linux, you're more likely to be waiting around 10. Okay, so this is real big considerations for people who are writing profilers. Obviously, when we're sleeping, we're not doing anything, and a thread sleeping can be quite CPU intense. Yielding is also another interesting thing, particularly if you're on Windows, because if you're on Windows and you see CPU starvation, then you might never have your thread yielded, because the Windows operating system will never relieve you, will never yield your thread. So when we were looking at XRebel, one of the things we didn't trust was the yield operation on Windows. What we might do now is we'll keep our volatile long time, we'll keep our run method, which this is our thread which is constantly grabbing the nanotime, but in our sleep we may consider putting in a platform-specific check to see if we're Windows. If we're Windows, then obviously don't yield, do something else. If we're any other platform, then yielding might be something we would choose. So if we go back to that kind of flow, the flow where we were sampling and we saw all the arrows drop down, how do you think tracing is going to look on this compared to sampling? How will this look? Sorry, a second. No? Anyone else? Pretty much, yeah. You're measuring all the horizontal lines. What we're effectively doing is we're performing checks at each entry and exit of every single one. So what we're effectively doing is measuring this time. You'll notice if we consider these circles to be the duration of time we spend in that instrumentation code, you'll notice there are some methods where you can't even see the horizontal line. And that's because very, very often with some methods that are very, very short, the instrumentation actually takes longer than the method itself. So one thing that we need to consider when we have short methods which are called many, many times is perhaps not just instrumenting it, but actually looking at the bytecode and saying, well, how many times is this run? We'll maybe mark it down, but not actually do the full instrumentation. So this is also true. But one of the nice things here is Baz, where's my pointer? Baz here and here isn't missed. Okay, so we will get far greater accuracy when tracing, but because we're tracing, we're measuring all these points, every single point, it's going to be more expensive. Okay, any questions? Yes.
So you told us not to trust Linux and the sleep on the virtual box. So what about profiling on virtual machines in general? Do you recommend it, or shall we always do it on real hardware?
Well, so the question is, the recommendation was not to trust a sleep on a VM and a Windows machine. VM and Linux. What else? What other options are there? So I guess this is going to be down to the profiler. So it's the profiler that chooses how it reacts to its underlying runtime. So for example, if a profiler notices it's kind of like Linux on a VM, on a virtual box or something like that, then it should say, I'm not going to use a sleep. I'm going to use a different method to do that. So it's not necessarily a user decision; it's a profiler decision. Okay. Any other questions? Yes.
Is there a way to check if the method is really occupying CPU or just waiting? Because I never type, and there are also methods that wait, for example, on a socket.
Okay. So is there any way of checking whether something is actually truly waiting? Like, for example, waiting on a socket, waiting on I/O, waiting on a response, or is it actually on a CPU running? So this is where, this can be tricky. It depends on the profiler, because if a profiler is just getting a pure amount of information about how long duration, then it's going to take all of that into account. But typically, when you look at a profiler or a CPU flow, you actually drop down, and you'll be able to see from the flow where you're spending your time. So just because let's say these are weights, you can see from this huge method call that you are spending maybe a large amount of time in and it could be as a result of these two weights. You'll be able to see that as you dig down. One of the other ways, if you're using something like JMC, or if you're using pure thread dumps, you'll be able to see exactly what the state of the thread is in. So it will literally say waiting or running or whatever, and that's another way you can check. Okay, so let's move on. So tracing, we do have a relatively high overhead for our faster methods, and there are ways around that. One of the ways of looking at it is we consider there to be a delta or an amount of error in our timings because of our instrumentation. And this is going to be a certain number, pretty much the same number for every single method. We're not going to do things differently for other methods. So the deeper we go in our stack or in our calls, the higher the multiplier of that error is going to be. If we have two branches, here, foo and boo. Boo is only going to have a single area of overhead, whereas foo is going to have 1, 2, 3. So it's going to look like, perhaps, depending on how granular we get and how big the methods are, our flows could easily be swayed by the amount of instrumentation there could be. Now, some profilers will actually perform calibration on that. And what they'll do is they'll actually say they're going to remove certain amounts of time from certain calls, and this is their calibration, pretty much to remove their own impact. It's the whole observation style overhead, right? When you observe something, it changes. So they try and remove that from themselves. Is it important to do that? Well, it kind of depends how much you care about the individual milliseconds, or whether you just care about an order. Where am I looking? Where should I be looking first, and so forth. Okay, so what other performance considerations should we have? If we look at our application now, which parts of our application should we really be caring about? What do you guys think? Where should you monitor? Anyone? I'll give you some clues. So third-party components, maybe? Database access. Database access is the typical one. Anywhere where you do huge amounts of I/O, whether it's database access, whether it's web services, RMI calls, caches. Are caches working? You're obviously using caches for a speed up. How can you test that? How can you be sure of that? Any kind of file system I/O as well. This is these can be the big killers. HTTP sessions. Developers love throwing stuff in HTTP sessions because it's easy and it's convenient. It's not always performant. When you render views, these can take huge amounts of time. Serialization, another big killer. Garbage collection, huge amounts of time can be spent on garbage. These are called GC pauses. Yes. Logging, another perfect one. Logging kind of fits in the file system access, but if you have your logging levels at a too high a level, you're just effectively slowing your app down because you're just throwing too much information into the file system. And yeah, this GC, if you don't have your GC tuned correctly, you could be in huge amounts of data, having actually safe points which are way too big because your GC pauses are way too big. So which questions should you be asking then? We know we should be monitoring the database. What is important? Why do we need to monitor the database? What might our application be doing wrong? So anyone know, for a database, what kind of stats might you get from a database? Index usage, anyone else? Queries, so both query number of queries, execution time. In the access logs? Oh, indexes, yeah, we had indexes as well. So yeah, where is most of the time spent as well? Let's have a look at a few. Where is most of my time spent? Very, very important for CPU profiling, because it's not just about having huge logs, but finding those bottlenecks easily. How many SQL queries we executed? Are my caches working properly? What's my HTTP session state? It's all very well monitoring, but it's really, really important to understand that we need goals. We need to understand what questions we should be demanding from our environments. So looking back at our path, we've talked about profilers a little bit, the traditional profilers which sit between B and C. But as we've talked already, the most improvement is already gained here between A and B. So is there a way where we can find tools that help us get from A to B, or maybe even start closer to B so that we haven't got these problems in our code? If this is where most of the improvement is gained, then that's where we want to start first. We don't want to get too complex in our performance issues until we find these bugs first. So I'm going to describe now XRebel, sorry. XRebel, that's done. XRebel. And XRebel is a new profiler, which I said is only a year old. And the goal of XRebel is to provide developers with the ability to fail fast. So in other words, find your problems, find your bugs as early as you can so that you can fix it before you even push your code changes out. So what I've got just Eclipse here, running Tomcat, and I have this pet clinic project in my workspace which is deployed on Tomcat. So what I'm going to do is I've enabled XRebel on my server, and if I come over here, this is my application, and you'll notice that in my application, it's lightweight, isn't it? One mate, it's rock solid, yeah. Right. There we go. So, okay, this is my Eclipse, as you may not have seen. I have a Pet Clinic application in my workspace, and I've got Tomcat, and we're all running on Tomcat. The other thing I've got is this is just my application. So I've got Welcome to DevOps Poland. This is a Spring application, and because we have XRebel running as a Java agent inside my runtime, what it does on every single request is render this toolbar. So irrespective of your application, you'll have this sitting in this left-hand side. It's not browser specific. It's not a browser plugin. It's just part of the response object to your call. Now, every time I click around, this is monitoring exactly what happens on the server side. So if I click around and I click Find Owners, all of a sudden we get a notification on XRebel. This, what I might have done is I might have just developed some code that behind this button, and I'm just going to quickly test it. As soon as I press that, yeah, everything seems to work. I get my information back. Okay, a developer might just say this works. I'm going to push it through. I'm going to commit this code. But we get this information, and if I click on that, we can actually dig down a little bit deeper, and we can see exactly where potential problems exist. So from here, I can open up exactly, see which SQL queries are running on my database, who's actually driving them, who's calling them, who's creating them, and this is a classic. What we actually see here is a classic N+1 problem, and I can explain to you who's heard of an N+1? Yes.
How do you actually find the SQL query? Isn't it driver specific?
It is driver specific. So the question was, how do you find the SQL query? Is it driver specific? It is driver specific. When we connect ourselves as a Java agent to the Tomcat process, what we're actually doing is we're instrumenting JDBC drivers, and we have a huge amount of support for a vast number of drivers, so that when drivers get accessed, we can actually see exactly what flows through them. So it is absolutely JDBC specific, yeah.
But if there is a new database that we don't have plugin for,
Then you can't actually write it yourselves, but it's the kind of thing that we would just write and support. Yeah. So if there is something like this that you need, just email our support team, and then we'll throw a support for you. So yeah, what we see. Who's heard of an N+1 problem? N+1 issue. Quite a few people, and I'm guessing that you guys are also Hibernate users, right? Okay. What an N+1 issue is? Let me ask some questions. What's your name, sir?
Steve.
Steve.
Rene.
Rene. Artois. You're going to see my pronunciation there. So I'm gonna as an application. This is all about pet owners and pets. All right. So I might say to Steve, how many pets do you have? 0. Rene.
1.
And 1. Okay. So now I have my 3 answers back. I've asked 1 question and I've got 3 responses back. Now what I'm going to do is I'm going to say, what's your pet called? Hector. What's your pet called? Cooper. So initially I asked 1 question to all 3. How many pets have you got? Then based on your responses, I ask 1 question for each person. That is what an N+1 issue is. Let's have a look at the actual SQL query. What I have done is I have first asked, how many owners do we have in our database? How many pet owners do we have? I get back 10 rows from my database, and it took me 0.1 of a millisecond to get that. The next thing this code does is it goes through the pet table, and it says, get me this information about a pet where my owner ID is 1, where my owner ID is 2, and so forth. And these numbers, this is information that I have got from my first query. So that's why it's N+1. My 1 is my first SQL query. My N is the number of queries that follow based on how many responses, how many results I get from my first. Now, if you're using JPA or Hibernate, one line of Hibernate or JPA can easily cause this. This can be fixed by a join, an inner join or something like that, and you can do this in like 1 or 2 SQL queries, but this is very, very typical. So what we do is, when a developer is developing their work, rather than just say, yes, this works, I get this information back, they can say, oh crap, 37 SQL queries, I need to fix that before I push it, because this won't scale. 100 users, 3,700 SQL queries at the same time. We blame the DBA, but it's not. It's us putting poor code in. We fix it as early as we possibly can. We can do the same thing with our CPU profiling. I mentioned CPU profiling and how we can go through the stack to find where our bottleneck is. What we see here is actually the flow of our HTTP GET, and we can see both how much time cumulatively we're spending through our stack flow, and also how much absolute time is spent in these methods. And we color code our absolute times so that we can see we're spending 13% of our time in this set value, we're spending 5.6% of our time in this JDBC callback, and so forth. And as soon as one of these turns red, you'll know that's likely going to be your bottleneck. So you can continue from there. So this is developer friendly. We give you just enough information so you can understand where to look. We're obviously not showing you, all information. There is a whole bunch of information out here which we're kind of hiding from you. We're just trying to show you, what's relevant to you. Any questions? Yes. How much time? So we're not hiding. So the question is there any way I can tell how much time you're hiding from me? So the time that we're hiding, I think it's if it's less than, I can't actually remember how much when we actually hide. The amount of time is included in this cumulative. It's not included here. So you will see the time here, but that amount of time, no, unfortunately not. But it's negligible, so it's not there.
So do you use sampling or?
The question is, do we use sampling or tracing? We use tracing. Yeah, so we instrument the code.
So do you subtract the overhead?
We do. I believe we do for small methods. One of the reasons why we chose to accept this overhead is because we are a development time profiler. And because we say, we only want to be on this left-hand side with developers, overhead doesn't matter as much to us. Yeah. Hi.
What if one of the methods spans 10 threads, for example? How would that be visualized?
So currently we're only working single-threaded. So currently, actually no, that's a lie. We initially only did single-threaded usage. So basically, all the work that was caused or created by that thread, if it was by a JDBC provider or so forth, it will be attached to the thread, and then we can push that up back to this request. But now we are doing some asynchronous work. So if you make an invocation, for example, to an EJB, you're going to be grabbing that from an EJB thread pool. Now we're connecting the threads, and that information will be pulled back as well. Yeah, we do handle Ajax queries as well, and that will actually be automatically. So if you're running an Ajax query on a website, the toolbar will automatically be updated by those queries as well. Okay, a couple of other things I want to show you before I pretty much run out of time. If I was to come in here as well, click on Add Owner, add some information. So we'll just say first name Simon Maple. If I click on Add Owner here. One thing you'll notice just here, let me make that a bit bigger for you, we have our session data. So this is saying that 80 bytes have been added to the session, and our session is currently at 264 bytes. I can open this up and I can actually look into my session, and I can see how big, how big each part of my session is. So 56 bytes for Simon, 56 bytes for Maple, and also how much of a difference it's caused. So in actual fact, Maple was an increase by 56. I actually turned Simon from 0 turnaround, which actually gives us back 16 bytes. So you can actually see if your session data is too big, if it's growing too much, or if it's just too big in general. If we wanted to, we could change some thresholds. So I might say, actually, I don't want my session size to ever increase. And as soon as I update those thresholds, all of a sudden the 80 byte growth turns into a notification. So you can set it based on your web app. All web apps are different. The last thing I wanted to show you, the last piece of function that we do in XRebel, hidden exceptions. So for example, if I click on add owner here, we get no exceptions thrown. But if I was to add, let's go to owner validator, where this code is validated. If I come in here and I just create a new exception, and I just call a print stack trace on that exception, well, I'm creating an exception, I'm throwing it away. All I'm doing is putting it to the log. This is in a production environment when you have a problem and there's loads and loads of crap exceptions and just stuff you don't want to read about. This happens really, really often. If I save that and rerun this, there is no error. There is no error in my runtime because it's a hidden exception. But we do now get a notification to say an exception has been created but not handled. I can click on that and it will tell me exactly where that exception is. Owner validator line 17. So I can come back, comment that out, rerun, and the exception goes away. I'm 2 minutes over, so I'm going to ask one question because you look very happy to ask that question. And then,
can I gather the information without web interface?
so the question was, can I gather information without the web interface? If you're using Ajax RS, you could do something like let's call pet clinic / XRebel, and this creates us the Ninja. Oh, you can't really see it very well. The Ninja UI. This allows us to run Ajax RS in the background and then see our results there. I think the question you may have been asking was maybe like more in a CI environment. And so the question is, can I do this maybe in CI and see my regressions on builds and things like that? Currently, no, but it's something I haven't done this session without being asked that question. So it's certainly something our development team are looking into. Whether it's this kind of product or a different product, it's just something that we're looking into right now. So I'm going to say thank you very much. If you're interested in something like this, feel free to go to XRebel.com. You can have 2 weeks for free just to try it out. It's it's literally 5 minutes to get going with it. Click around your application, see how it's working, see how many SQL queries you've got. Other than that, thank you very much.